schedule now because this session is the last one before dinner tonight, so we'll go really quick and everybody gets dinner. Using ammonia safely follows on really nicely from Jan Boon's presentation at the end of the previous session, if you were here for that. I want to cover a few topics here. Ammonia as a refrigerant, the hazards that we face, a little bit about the kind of accidents that happen with ammonia when they happen, and then how we can reduce the risk and some of the new design concepts that we've talked about. So ammonia as a refrigerant, this is just as a guide. It would be wrong to say that if a substance has a very high critical temperature then it automatically is a good refrigerant. But the critical temperature is a nice indicator of a substance that you can probably use well. You can still do it badly as well. But looking at critical temperature for different substances, ammonia is the green one on the left-hand side and has a critical temperature of about 133 degrees C. There are things with higher critical temperature. You can see there's butane in there with a critical of about 150. The blue ones are R12 and R22, and they were reasonably good. The purple ones are the things that we're using generally to replace R12 and R22, and you can see the critical temperature generally is lower. That doesn't necessarily mean that they're worse. It means that it's more difficult to make those systems as efficient as the R12, R22 systems. But you can see that ammonia has a really high critical temperature. And this next graph kind of was already in Jan's presentation as well, showing the operating temperature range you can use them. And ammonia is good over a very wide operating temperature range. And that's because we can take it right up into the 110, 120 degree operating range at the hot end of the system. And we can take it below atmospheric pressure, minus 33 for ammonia, because it actually works okay in a vacuum if it's being slightly contaminated, unlike the CFCs, HCFCs, HFOs. So we've got an extended bottom range for ammonia. So it makes a great refrigerant, and that's just two of the many, many, many reasons why. So we're going to play a little game of I'm guessing what you're thinking and then I'll answer your question. Okay, so the first question you might be thinking is, yes, but ammonia is dangerous. And the answer is, yes, it is dangerous. It's flammable and it's toxic. And you need to recognize that. Lots of things that we deal with on a daily basis are dangerous. My favorite example for many, many, many reasons is ethanol. Ethanol is also flammable and toxic. But we know how to deal with it. We take the neat vodka and we put orange juice in to stop it from being quite so flammable. We take aquavit and we set fire to it to make sure that it definitely is flammable. So provided you deal with these things, that's okay. So you might then be thinking, well, if ammonia is dangerous, are ammonia plants safe? And the answer is absolutely, ammonia plants are safe if they're designed and operated correctly. And what I go into in my presentation will be showing you that when, unfortunately, injuries or fatalities occur and they're related to ammonia plant, it's because something was not done sensibly or correctly, and the guidance that already exists was not being followed. So if that's the case, then it would be a mistake to change the guidance. You need to change the attitude of the people who are not following the guidance. So looking at a few just general comments about ammonia accidents. They're generally very rare. In the refrigeration community generally, we set ourselves an exceptionally high standard on accidents. If you look at either the European standards or the international ISO standards or the American ASHRAE standards, they set an extremely high standard. If you look for comparison at the use of hydrocarbons, natural gas, methane, in the home as a fuel, the standards set for safety are not nearly as high as the standards set for refrigeration, and the accident rate is higher as a result, and that's deemed to be acceptable. So it really puzzles me, why do we set a higher level of safety for refrigeration than we do for other circumstances? It's very, very hard to get statistics on this. Alex Pashai is working on behalf of IIR, trying to gather accident statistics, and it's really tough because there's not many accidents happen, and when they happen they're not necessarily terribly well reported, and when they're reported they're not necessarily giving the whole story, and people are very reluctant to talk about their mistakes in public, so it's very difficult to get this information. You have to kind of piece things together. with ammonia, as with all other refrigerants, when an accident unfortunately does occur, it mainly affects the people who are directly working on the system. You do hear of huge ammonia releases that affect the neighbourhood. These generally are not refrigeration plants, they'll be fertiliser plants or other things. The injuries are rare and they're not well documented. You do tend to get fatalities documented, they're exceptionally rare. Injuries, slightly more common, but less well documented. And the key thing there is that the injuries, if it wasn't a fatality, it's probably a very minor injury. There seems to be very little middle ground of people being really seriously incapacitated. It does happen occasionally, but it's exceptionally rare. It's either a fatal accident or it's a minor accident. There's kind of very little middle ground. And the press reports are often extremely misleading. I read one press report of an ammonia explosion. It turned out that 2 road tankers had collided. This was in Romania. One of them was carrying ammonium nitrate and the other was carrying diesel oil, and they collided and there was a big explosion. That's what you get when you mix ammonium nitrate and diesel oil. You get big explosions. It wasn't an ammonia accident. The explosion in Texas in the fertilizer plant was originally described as an ammonia explosion. It wasn't, it was a fertilizer explosion. The people writing these press reports don't understand what they're writing about. They're not scientists, they're not engineers, they're journalists. So if you read about it in the paper, you can be sure that something happened. You can be reasonably sure that it's not what has been written down. And there's an example here. This is from just 2 weeks ago in Copenhagen, where there was an ammonia leak in a shopping mall, which used to be the fish market. And what the newspaper journalist is trying to say is that the shopping mall managers were negligent because they didn't evacuate the building despite the fact there was this major health hazard. And what the manager was saying was the ammonia release did happen, but it wasn't at a high enough level to set off the alarm system, and therefore there was no need to evacuate. Now, if that alarm system was in the machinery room, unfortunately the journalist, because he doesn't know what he's talking about, didn't tell us what the alarm system was set at, so we don't have the critical piece of information. If it was in the machinery room, it was probably set at 500 parts per million. And that would be a very hazardous situation in the machinery room for the technician working on the plant, but it would not represent any kind of a danger to the general public because the machinery room is properly ventilated and the ammonia that's in there would be taken away at high level and discharged to atmosphere. If the sensor was in the shopping mall to make sure that the public were safe, it was probably set at 25 parts per million because that's a normal setting for that type of application. And if that was the case, then 25 parts per million is the level of ammonia that you can safely work in 8 hours a day for every day of your working life without suffering any adverse effects. So the manager was totally correct if that alarm was not triggered to say there is no need to evacuate the shopping centre. It still smells. You can smell ammonia at 25 parts per million. So what this very, very dramatic newspaper article is really saying is there was a bit of a smell down the fish market today. Well, that's not really a very exciting news story, is it? So beware of what you read in the press. There are probably just as many serious incidents with HFCs and HFOs, particularly fatalities, particularly asphyxiation. It does also happen. The numbers are of the same kind of order of magnitude. I did a study a while back looking at fatal accidents in the UK, in France, and in America. And in all 3 cases, despite the fact that they have very different approaches to ammonia safety, the fatal accidents ran at a level of about 1 in 1 billion people per year, 1 per 10 to the minus 9. Now, the level of safety that's generally accepted as being acceptable to the general public is 1 times 10 to the minus 6. So we're 1,000 times safer than what is generally deemed to be acceptable. Despite the fact that in Britain we're very lax about health and safety law, the law says if you had an accident you're guilty, if you didn't have an accident you're innocent. In France they're very heavily against ammonia and they say don't use ammonia, they make it very, very difficult. In America they're happy to let you use ammonia, but they prescribe in great detail exactly how to do it. So it's 3 different regimes, but all with about the same fatality rate. It's really quite strange. In other words, it's the stupid things that people do on the spur of the moment that cause the problem, not what it says in the law or the safety standard or the textbook or anything else. So it's that natural human reaction, and there is a certain level of accident occurrence, which kind of is the starting point for that. So the worst aspect of all of that is probably the bad publicity that this causes. Ammonia does smell at a level which is perfectly safe to work in all day, every day of your life. So it will generate a very negative reaction from people who are not familiar with it, the shoppers in the shopping centre, for example. I'm not trying to minimise that. That is a serious concern. It was serious bad news for the shopping mall that they got such bad publicity. But if the situation had been dealt with in a more measured manner, then the headlines need not have been in the paper. The problem is not the ammonia in that case, it's the way that people were using it. Back to my previous slide, is it dangerous? No, it's not. It's perfectly safe if you use it correctly. So, I want to look at the reality of situations. Ignition of ammonia is pretty much unheard of in Europe because of the way our safety standards are written. If the alarm is triggered at a level which is a tiny fraction of the lower flammable limit, then all of the electricity to the machinery room is cut off and the ventilation is started at a rate of about 1 air change every 4 minutes. It's impossible to ignite ammonia under these circumstances. So you will not find instances of ammonia ignition in code-compliant plants in Europe. It does happen a little bit in America. There are a few instances, although it's still very, very uncommon. They have a different approach. They try to use exceptionally high ventilation rates to avoid the ignition. And to be honest, I don't believe it's as good a way of achieving that goal as the European way. But the ignitions that I'm aware of have been when there's been some other code violation as well. So it's wrong to say that their code is inherently bad. Toxicity incidents do happen slightly more frequently, but as I said previously, almost exclusively only affecting the technicians who were working on the plant. There was a really sad example of that in Canada last year with the ice rink incident you may have heard of, where 3 technicians who were responding to the fact that there was an ammonia leak had done something stupid quite a while previously, and it resulted in a sudden release of calcium chloride brine with ammonia mixed in with it, and they were overcome by the fumes because they were standing right next to the plant. Even an incident like that didn't have any effect on the neighbourhood, on the people living next door. So the defence mechanisms are to have suitable procedures, to have trained people who know what they're doing, and to have them wearing appropriate protective equipment. And then, despite the toxicity of ammonia, it is safe to work with it. And the same actually goes for HFCs and HFOs as well. If you're not using the correct safety equipment and you're not following the correct procedures, you will get yourself into trouble. And again, it will be the technician who gets into trouble. It will be the guy who's actually there working on the plant. And again, with ammonia, the downside, the negative piece here, the bit that we can't ignore, is the panic reaction. People who are unfamiliar with ammonia is probably the worst aspect of this. It's a legitimate concern, and anybody planning an ammonia emergency response system needs to bear that in mind, that you will be putting people into a situation with which they are very, very uncomfortable. So, a few myths and misinformation about ammonia accidents. First, that the public could be surprised and overcome by ammonia. It just doesn't happen. Even if they're only a few meters away, 20 meters, 30 meters, they're too far away for that to happen. Ammonia doesn't sneak up on you and surprise you. Nobody ever walked into a cold store and was overcome by ammonia because they didn't realize it was there. It has happened with R22, it has happened with R134A, it has happened with R123. It hasn't happened, as far as I'm aware, with ammonia, because the smell at 25 ppm is really horrible. At 100 ppm, it's extremely nasty. At 400 ppm, and I've stood in 400 ppm of ammonia, you don't want to be there. You can't keep yourself there. You want to get out. So 400 ppm is not going to overcome somebody. 4,000 might, but you don't get from 0 to 4,000 in an instant. So it doesn't surprise people. And even people with no sense of smell know that it's there. 300 ppm is described as immediately dangerous to life and health. That's the phrase which is used in the safety standards. That means that's the level that would cause you difficulty getting out of the room in 30 minutes. So how many people would take 30 minutes to get out of a machinery room? It doesn't work that way. 1 minute and you're out. So 300 ppm is the level that would be dangerous if you took 30 minutes to get out of the room. So that kind of puts it in context as well. People say to me ammonia shouldn't be used because there have been multiple fatality incidents, particularly in China and in India in the last few years, and there have been really tragic incidents. and in all cases because there was blatant disregard for the safety of the individuals working in the facility. For example, the emergency exits had been locked so that they couldn't be used. Now this was happening, for example, in the USA 100 years ago, and stringent laws were enacted to prevent it from happening, and the level of fatalities dropped dramatically. But the interesting thing is, in that case, the safety code came first and the law came after. And the safety code is already there in China, but it's being ignored. So it's enforcement that's the problem, not the safety standard. I've also heard on many occasions ammonia fires cause cold stores to burn down. I had a group of French insurance company engineers trying to tell me this. They said, oh, ammonia is terrible because we've had a lot of cases where we've had to pay out on a claim because a cold store burnt down. And in each case, I said, you've got 10 cases here. Tell me, why did the cold store burn down? Oh, there was an electrical fault in the wiring to the evaporators. So it was nothing to do with the ammonia at all. Oh, well, that's true, it was nothing to do with the ammonia at all. But it's getting the blame for it. So it's a myth that ammonia fires happen in that way. There was a case in China, and I've heard this said several times, an ammonia fire that killed 120 people. It was a chicken factory, 120 people died. It was absolutely tragic. It was an electrical fault in a building which was not built to code, using flammable construction materials, and most importantly, again, the emergency exits were locked to prevent thieving from the production line.
Stealing chicken from
yes, exactly. It was an ammonia plant, and the ammonia burnt in the fire. The ammonia did not cause the fire, the ammonia did not start the fire, and the fatality rate would have been at least the same, if not higher, if it had been an R22 plant. So bear that in mind. If anybody tells you there was an ammonia fire in China that killed 120 people, you have to say to them, it's simply not true. That's not the issues that face us as regards ammonia safety. We're looking for time, nearly there. So reducing risk, lots of things to do. And I want to talk a little bit about modern low-charge ammonia systems, because they do all of these things. They are a multiple attack line to reduce ammonia risk and improve safety. Package units like this, there are several different types, where all of the equipment is outdoors, it's in the fresh air, the charge of ammonia has been reduced to a much lower level than traditional, and defrosting is done by using, for example, a reverse cycle defrost method, which is quick and easy. So in conclusion, the advantages of ammonia as a refrigerant, as I showed you with operating temperature range and critical temperature, the advantages are real and they're valuable. And the measures required to make ammonia systems safe are not difficult. We're doing it all day, every day, and they're not expensive either. I really don't understand why people cut corners, because they're not actually saving themselves money, and they would save themselves a huge amount of hassle if they didn't cut the corners. The alternatives that are promoted as safer, the non-flammable, non-toxic so-called, are just as dangerous if they're done badly, in the same way as ammonia is dangerous if it's done badly. And I would say that direct ammonia refrigeration offers the lowest cost of operation of any cooling alternative for industrial refrigeration, and it can be applied safely in many other applications as well. So we should start really attacking these myths and misinformations that are around us, because they're actually damaging our industry and our economies by keeping people away from ammonia. So that's my 20 minutes. I think we need to move on. If there are questions, we can get them later. I'm going to hand over to Pega now.
Thank you.
Thank you.